So for this next system, we also got a little lucky because, again, the goal is to go from a 3x3 system to a 2x2. All right, and you'll notice that one of my equations, the third one, already is in a nice useful form, right? Because there's only two variables in it. So really what it comes down to, right, is choosing a variable to solve for here, right, and making a substitution to get into there. And so because of where we're at, right, because this is in terms of x's and y's, we might want to solve for z in one of these two equations up there, right? And so pick your poison. They both have a 2, right? I like the fact that this is a positive 2. So let's take this guy and solve for z. So when I do that, we get, let me make sure I wrote it down right. So I'm going to subtract x and add 4y, right? So I'll do that to both sides. We get 2z equals negative x plus 4y minus 2. If we divide everybody by 2, we end up with z equals, it looks like, negative 1/2 x plus 2y minus 1. All right, and so this, I'm now going to come and substitute into that other equation. So we get x plus 2y minus 2, and again, changing colors and parentheses, I can substitute that for z. Right, and then we clean this up. So we got, let me change back. We got x plus 2y. If I distribute, a negative times a negative is a positive. 2 times a half is 1, so we got x. Negative 2 and a positive 2y is negative 4y. Negative 2 and negative 1 is a positive 2 equals negative 3. So if we clean this up, x and x gives us 2x. 2y minus 4y is a negative 2y. And if we subtract 2 from both sides, we get negative 5. So there's our new equation. And then combining it with this one, here's my new system, right? 2x minus 2y equals negative 5. X minus y equals 4. All right, so there's our new 2x2 system that I now have to solve for. And again, what I'll do, since we're using substitution, I'll continue to use substitution. So just like we did before, I got to choose, which equation do I want to solve for? Well, how about we solve for x right there? So if I solve for x, we get that x equals y plus 4. Take that value and substitute it up here. So we get 2. Let me show that substitution with like that. So we get 2y plus 8 minus 2y equals negative 5. The y's actually cancel out, and we're left with 8 equals negative 5. Right? And so that basically tells us, right, that that's not true. Right? So this is no solution. So even after all that work, right, we find that nothing is ever going to work because we end up with a situation that's never true. So again, it's pretty hard to solve this method with substitution. You can kind of see the idea, the goal. We either get really lucky and we end up getting a 1x1 and then we just back substitute, or if we do end up with a 2x2, you just continue to use substitution, solve for one of the variables, and then I got lucky again here because there was no solution. But you can imagine if we did get x equals 2, I can now go back and solve for y. And then I can take those x and y values and come back up here and solve for z. So I just go through that back substitution as I go through. Right? It does turn out that 3x3 systems elimination works a little bit better, right? But what we really do is we start using matrices. But there, right, is the nuts and bolts behind solving a 3x3 system using the substitution technique. Let's go look at elimination for this, but I'll do that in any other video coming soon.